Okay.
Okay, so this is the first day for the lecture about the DC circuitry. Okay, so you understand if you want to be a technician, then you have to really understand very, very basic thing. Okay, otherwise, we cannot help. So, first thing is direct current, that stands for DC. Okay, DC, that direct current, and AC means alternating current. So now you can see, okay, if you're looking at the DC voltage on the display, you can see they get only the straight line telling me how many voltage. Okay, and the DC voltage easy for you to see where, like your car battery. Okay, how many voltage on the car battery? You understand that will be 12 volt. Okay, and when you see the batteries, okay, and the DC voltage, you can get a positive and another one will be a negative. On your car battery, you see the red one is a positive and the black will be the negative. So that's a DC voltage, okay? And another signal, they can go out. AC, alternating current. You can see that the AC. And this signal later on, the name will be the sine wave, okay? And the signal will be vary with the time. This is the time. Second, millisecond, microsecond, okay? And this signal will be positive, and then they will be negative, and they keep going forever. That means the voltage will be vary with the time. That's what the AC. Now, if you're looking into your house, the outlet coming out, that will be 110 or 120 volt IMF. That's the AC. If you're looking at the signal on the oscilloscope, you can see they will be look like, okay? That's 120 volt IMF AC. Now, however, in all of the equipment, most of the equipment using in your house, they cannot using the AC. They need the AC, but they cannot use it. They have to be converting into the DC. For example, your computer, they're not working directly with the AC voltage, but they're working with the DC. Like you get 5 volt, or 3 volt, 12 volt, -5, -3, or whatever. That's a DC voltage. Also in microwave, the coming in will be the AC voltage. However, they must converting to DC inside the microwave so they can work it, okay? So now you understand between the AC and the DC. not much thing to talking about DC at this time right now. I'm talking about AC. That's the one you will have to deal with. This signal we call the name, we call a sine wave. Okay, that the name equal the sine wave. Okay, and they will be vary with the time here. That's what they call a time domain. Okay, time domains. That means the signal vary with the time. And you also get another domain. They call a frequency domain. Okay, and the frequency domain will be vary with the frequency. That means when you're learning related into the radio frequency, then you will be learn radio frequency. Okay, now we deal with the time domain. This signal will be displayed on the equipment we call oscilloscope. Oscilloscope will be a time domain. That means you can see this signal here. And now, this is just a definition. The voltage from a 0 up to the top or 0 down to the bottom. That's what they call a VP. Okay, VP. For example, in this example here, 0 to the top, you get a 5 volt. So that's why they say V peak equal 5 volt. And the voltage from the top to the bottom here, they call a peak to peak. So they basically you can see peak to peak will be a double of the V peak. So V peak to peak equal 2 times V peak in this case will be equal 10 volt. Okay, and another few things you need to know what the VRM is. That means the voltage root mean square, or we call it effective voltage. Okay, they're telling you even to see the signal will be a bit like that one. However, when you're using, they're not using everything. They just use part of that. That's what they call VIMS. For example, for in your house, outlet they coming out a sideways. If you're looking in on the oscilloscope, you can see that a sideways with 370 voltage peak to peak. Okay. However, they're not using 370 volt. They're using only 120 volt. That's the voltage we call effective voltage. Okay. So in order to calculate the VIMS or effective voltage, you apply 0.707 time with the VP. Okay. So that's why they given you the value for VIMS. And then when you're looking into this sideway here, when they start going up, then they going down. Okay, however, when they try going up again, that's what they call a one complete cycle or period, T. Okay, T will be called period. Or you have to understand that just a complete one cycle. Okay, and also you can get the frequency. In order to get the frequency, you measure it up. Just a minute. I am on Zoom now, okay? I'm on Zoom now. Okay, so you can say frequency F, the unit will be in hertz, kilohertz, megahertz, okay? And the relation between the period and the frequency, you using the formula T equal 1 over F or F equal 1 over T. That means if you get the period, then you're able to calculate the frequency. The reason is when the signal display on the oscilloscope, they're not telling you the frequency. The thing is the time domain. Only they telling you the period, T only. So if they want the frequency, then you must be using F equal 1 over T to get the frequency. Okay? This is a very, very basic definition. When you're looking into the sine wave, you're able to recognize everything like we just showed you. Okay? In here, I already given you some definition. Hello? Okay. Let's see. Okay, okay. Okay, sorry. The thing is students, they try to get into the Zoom, but she cannot. I don't know how come. I don't know. Okay, anyway, cycle definition. That one complete occurrence of repeating wave period signal, such as one positive and one negative alternation of the sine wave. Okay. What the definition for frequency? The number of cycles of a signal that occur in 1 second. Okay. And period, the time distance between two similar points on a periodic way. Okay. Now, the next thing we try to get along with that, common power of 10. Okay. Multiplier. So basically, you know, you get 1 million here and you get 10 to the power of 6. Oh. Yeah, I get some problem. Someone want to get into the Zoom, but they look like on mine, they frozen. They not show up. Okay, so 1 million, the same thing, 10 to the power of 6, 100,000, power 5, power 4, 3, 2, 1. And 1 will be equal 10 power of 0. Okay, And also this will be given to you a negative power. Okay, negative minus 6, 10 power minus 5, minus 4, minus 3, minus 2, minus 1. Okay, so to handle with the large number in electronic system, use power of 10 notation. Okay. Không có được thì thôi tôi đang giảng bài. Ok. The number 10 equal the base of 10 or base 10 and its power equal exponent. You get a number 247,000 and now they want to change, okay, to the power of 10. So they can get 2 points. That means you stay right here. You can count how many digits left over. 1, 2, 3, 4, 5. That means 2.47 times 10 power of 5. Okay. Like the other number, 0.00369. So they want it change to the power of 10. So you pick right here the first number, 3.69. And now you have to know before number 3 how many digits? 1, 2, 3. So that's why they will be a negative power minus 3. So if I given to you a number I want converting to the power of 10, then you know how to do it. Okay. This is just a very, very basic thing. Okay. We have to get through in order to keep going. If you get a question, please stop me. Okay. Next one. That we'll be talking about multiplication and division using power of 10. Okay. To multiply number in power of 10 notation, multiply their base number, then add their exponent. Okay. Thus, you get a 1.2 times 10 power of 3. Multiply to 1.5 times 10 power of 4. So basically, they're telling you just get the number tied to multiply by the number. Okay, 1.2 times 1.5. However, the power, you have to add them up. So that's why you get 1.8 times 10 to power 7. Okay, and if you want to divide it, okay, then they're telling you subtract the exponent in the denominator from those in the numerator. Okay, if you divide 4.5 times 10 power of 2 to 3 times 10 power of minus 2, what you can do? Divide 4.5 to number 3. Okay, and the power here will be subtracted. So now you can see 4.5 divided to number 3, you get 1.5. And the power you will get 10 power of 2 minus 2 minus 2. So you get 10 power of 4. Okay, so any question up to this point? Is that you guys listen to me?
Yes,
Hello?
I'm listening.
Okay.
Yep.
So now, up to that point, okay, at this point right here, no question. Now you're doing for me. I want converting number power of 10. Notation. 276 times 0.09. Okay. That's what I need you to do by your time. Okay. The thing is we don't want to do in here. However, I already given to you the answer right here. The answer will be 2.484. Okay. Only thing is later on, when you go to the handout, you try to do it, you cannot get the answer right, then you can asking me. For example, 98, 200 divide 20. Okay, so you can get answer will be 4.91 times 10 power of 3. Okay, now they're talking about adding and subtraction. Okay, basically add or subtract. Okay, first add your own number to the same power of 10. It does not matter what exponent you choose, as long as all are the same. Now they want to adding 3.25 power 10 power of 2 to 5 times 10 power of 3. Okay, what you have to do, make sure you must get the same power. Then you can add or subtract it. So in this example here, you can say, I want power of 2. That means you must be change that 5 times 10 power of 3 to power of 2. Okay, then you can add. Or if you want power of 3, that means you keep this guy, but you must change this to power of 3. They've given you the example here. Answer 5 times 10 power of 3. Okay, so they want power of 2. That means they going down by 10 from 3 to 2. Then you have to multiply this number by 10. So that's why you get 50. Okay, so 3.25 times 10 power of 2 adding to 50 times 10 power of 2, that means you can get the answer. But finally, you want to adding or you want to subtract it. They must be the same power. Okay? Now, raising a number to a power. Okay? So basically, this one, you can go through it. Okay? If you still not quite understand, next time you can bring it up, I can help. Otherwise, we don't have enough time, okay, to get to what I wanted. For example, you get 2 times 10 power of 3 and now you square. So basically that's a very easy, okay? That means you square of 2, okay? 2 square of 2, 2 times 2, you get a 4, okay? And the power here, you take 2 times 3, you can get power of 6, okay? So this is a basically general formula. And also, they can tell you, you take a square root, okay? Square root of 4 will be 2, and you can take a square root, any number. But the thing is, it will be not a big deal. You get your calculator, okay? You can do it. And also, make sure you looking into the example, okay, and try to see you can get the same what we get or not. This is just a very, very basic thing a lot of people already know. And the next thing, engineering prefix. That means you get a 1 power of 10 and the prefix, what they call 10 power of 12, they call a tera, power of 9 giga, power of 6 mega, 3 kilo minus 3 milli micro nano pico. Only thing I want to make sure you understand and memorize. When I say kilo, then you have to understand that will be 10 to the power of 3. When we're talking about milli, that means 10 power minus 3. Or we're talking about pico, then you know that will be 10 power minus 12. Okay? Sometimes you couldn't remember. However, if you keep doing, then that will be help. Okay? You can get along. For example, they say I get a 0.1 megavolt. I want to change to the kilovolt. Let's see. How do we convert it? 0.1 mega. Okay. And you want to change to the kilo. Then you multiply by power of 3. So you get 100 kilovolt. Okay. And also this will be, they say they want expressed in engineering notation. Okay. And this is A or B or C. We already given you the answer. You have to exercise. Okay. Now, we go into the DC. You know that is your car battery. Positive and also negative. And this is your headlight lamp. Okay. And this is you turn on or turn off the light. Okay. So what happened? When you turn on the light, so the current will be flowing from positive, okay, to the negative. That turn on the light. Now, the question is how come we get the current? Okay. The reason you get the current is you get the electron from the negative here, move into the positive. This electron causing the current flowing. So that's why they can call electron current. Okay. So normally we not deal with the electron current. Okay. The thing is electron current, they can draw the arrow going this way. Okay. From the left to the right. Not like that one. From the right, you know. This is from positive to the negative. And the other current can go the same, but from negative to the positive. That's just telling you the current flowing. Okay, but we're working with what they call a conventional current. Conventional current all the time, they will be drawing going from positive to the negative. Okay, so I telling you that way. The thing is when you reading the textbook, most textbook they draw the current the other way, from right to the left. That they draw electron flowing. Okay. However, we deal with the conventional current. Make sure you understand that. Even the same current, but they flowing positive to the negative. Okay. So that will be telling you this current only flowing from positive to the negative only. So that's why they call direct current. Okay, they cannot be changed only from positive to the negative. Okay, next, resistance. Okay, resistance is the opposition to electric flowing. A component manufactured to have a resistance equal a resistor. Conductor like copper have a little resistance. Okay. This is the symbol for resistor. Okay. Who already working in electronic assembly, then you recognize that. Schematic symbol, this is a schematic symbol. That means when you're looking at a schematic, you see this symbol, you know this is a resistor. The letter symbol is R. Unit of resistance will be in ohm. Okay, and this is a symbol. So they can be in ohm, they can be in kilo ohm, they can be in mega ohm. Okay. This is just given to you the picture for structural module, carbon composition resistor. Okay, so that's just for you to look into that. We don't care this thing. We don't have to do anything with that. Another type of different resistor here. You see 1, 2, 3, 4, 5. So basically the size bigger, they will be carry more watt. This can carry up to 2 watt. And this is 1 watt, half watt, quarter watt. Okay, 1/8 me a watt. That means for this example, this only a quarter, a half watt. If you apply more current, they will be cook the resistor. Okay, they just telling you bigger size, they can handle more power. Okay, and these are different type of the resistor. Okay, so that's just a more information helping you when you're working. You can see if they look like this thing, they just a resistor. Also, this is also okay resistor network. That means you can see. Let's see how many pins it here. 1, 2, 3, 4, 5, 6, 7, 8. So basically inside it, I see here, they can get around 7 resistor. Okay. Instead, you have to connect different 7 resistor like this one. They want to save the room so they can put everything inside one IC. That is normally they're doing now. So that's why they can make your cell phone smaller and smaller, okay? They need the room. And another one, that's what they call a variable resistor. So basically, this register, you can adjust to a certain resistance value you want. For example, this is a variable for 10 kilo ohm. That will be telling you you can adjust to get any value of resistor from 0 up to 10 kilo ohm. Okay? That's not much using. The thing is that you have to be using manual intervention. That means you have to using your hand to turn it, okay, to get the value. Then now, resistor color code. So this is the resistor here. On the resistor, they get the color code. They get 1, 2, 3, 4, 4 bands. And this one, they get 1, 2, 3, 4, 5 bands. Okay? If you're working at a assembler, you're looking in the color code, you can tell what the value of the resistor. Okay? As a technician, if you know that, okay, that's good. However, if you don't know, we have to get the other way to get the value. Okay? Right now, I'm talking about color code to make sure everyone know by looking into the color, you can identify what the value. Okay? So for the general purpose, they get 4 bands. For the precision, you get 5 bands. The difference between general purpose and the precision is the precision will be get more accurate value, okay, than the general purpose. So if you want to buy the one resistor for the general purpose, cost you 5 cents. However, the same thing, you want it to be a precision, you have to pay 25 cents, cost much more, okay? So now, by the definition, first band, that will be a first significant digit. The second one, second digit. The next will be multiplied, and the last one will be tolerant. That apply the same for precision. Okay, now this is the table telling you if you get the color, then you're able to identify the value. Okay, like you get a brown, the first band will be number 1. Okay, and second band, okay, if you get a red, that means you get number 2. That means 1, 2. And now the third band, okay, if you get a brown, that means you will be multiplied by 10 power of 1, okay, and the tolerant, okay, the tolerant, that means the 4 band here, if gold, you plus minus 5%, silver plus minus 10%, okay, if you don't have any, that will be 20%. Now I given you, okay, this one you can look over. They will be doing exactly the same. Only thing you know how to working with a general purpose. Then you're able to understand for the precision. Only thing is they get 5 bands. First one, first digit, second digit, third digit. And that's still multiply and the tolerance. Okay, now if I get this one, okay, first one is brown, second will be the gray, next will be orange, and the last one here will be gold. We don't care on this part right here. Okay, now try to find out what the value. Okay, first one you see is the brown. So what digit for the brown? Brown is 1, right? First digit, that's the 1. Okay, brown is number 1. So that's why you get number 1. Second will be gray. And if you're looking in here, gray will be number 8. So that's why you get number 1, 8. The next number 3 will be multiply orange. Orange number 3. That means 10 power 3. Okay. So they will be multiplied by 10 power 3. Okay. And the last one, gold, tolerant. If you look into the tolerant, you can see that will be a tolerant gold will be under here, plus minus 5%. So the answer will be, okay, 18 times 10 power 3 ohm, equivalent to 18 kilo ohm. And now plus or minus 5%. I want to know you guys understand what that means for the tolerance. Okay, for example, plus minus 5%. Okay, the thing is sometimes you can see you get 18 kilo ohm, but no way you can get exactly 18 kilo ohm. Okay, so everything must get the tolerance. Like they want to measure the 5 volt. 5 volt, you cannot exactly get a 5 volt. Okay, they must be get the tolerance. Okay, now we're talking about tolerance for this problem here. 5% of 18K. Then the first thing you have to calculate to see 18 kilo ohm. 5% means times 5 divide 100. Okay, then what you get? 5, 8, 40, that look like 90, right? 90 divide 100. That means 0.9. Okay, 0.9. Okay. Okay, so the tolerance will be at 0.9 K. Now we have to calculate to see what the maximum value or what the minimum value. Okay, so the maximum equal 18K plus 0.9. That given to you. Okay, 18K plus minus okay, 0.9. So given to you maximum will be 18.9 K. Minimum value 18K minus 0.9. Okay, 18 minus 0.9, 17.1. Okay, so now you get the value. Okay, okay, right here is 0. So you get maximum 18.9K, minimum 17.1K. So any value between here will be okay. Any value higher than maximum or less than minimum is not good. So now, if you measure this here, you get 20K. Is it good or not good?
Not good.
Not good. The thing is they higher than maximum value. Okay. So if you get you measure about 17.9, okay or not? If you measure 17.9 kilo ohm, good or not good?
Good.
Good. Perfect. To try to get along with that, you have to deal with all the time. Okay? The thing is, whenever you measure something, you cannot get exactly value. They must be plus or minus some tolerance, 5%, 10%, or 20%. Okay? So any question up to this point?
Yes, I have a question.
Yeah, go ahead.
How do you determine it's over 100?
You mean over 100 here?
Yeah, why do we divide? Yes.
The thing is 5%. That means you multiply by 5 divided by 100. That means 5%.
Okay. Okay.
Okay?
All right, thanks.
Yeah. Normally, they given you the tolerance. They have to be percent. Okay, let's see. A resistor manufacturer produce carbon composition resistor 100 mega ohm with a tolerance of plus minus 5%. What will be the color code on the resistor? Okay, so that means they given you already the value of resistor, and they want to know backward. I want to know what the color. That means you have to go in back. Okay, and also like the tolerance 5 or minus 5%, we already know the goal. And this one, you can do it, try to calculate it. They already get answer. Okay, I'm not go to that. And also the other example, they given the resistor with the color brown, green, yellow, silver. They want to know the value, plus or minus how many percent. Okay. For this one, can you tell me plus or minus how many percent for the A? Who's telling me for number A? I don't care about the value right now. I care about tolerance. How many percent?
Can we see the chart?
You run the chart. Okay, that is the chart.
Yes, please. The silver, plus or minus 10%.
How many? Can you say again?
Plus or minus 10%.
You say plus minus 10%, right?
Correct.
Not right. You
Not
know,
right? Ah, man. Put me on the spot, man. Call me out. I look like a fool.
Hmm.
how many
Didn't it say
percent?
silver? I thought it said silver band.
Plus minus what? Okay, I'm telling you. On this one, they get a 1, 2, 3, 4. They don't show the number 5 for tolerance. Okay. If you don't have a number 5, okay, if you're looking into here, that means the tolerance on number 5 right here. If they say none, that means no color at all, nothing. They must,
You set me up. That's cold-blooded. So it's plus or minus 20%.
exactly.
That's fantastic. Cool.
That's what I want to make sure.
I look like a fool.
Okay. And this one more. I want this one. How many percent? Red. So basically, let's see.
Right? So is it plus or minus 2%? Or am I wrong again?
That's what I got.
I'm trying here.
1.
1.
Is it
No,
the
plus or minus 2. Made me look like. I got it. I got it right. We got it right.
red
We
one,
did it.
right? Red is a plus or minus 2% for precision. The thing is on the general purpose, you don't have a red color. But that did not make sense to me. The thing is they given to you 1, 2, 3, 4, 5. Now, if you're looking into that one, 1, 2, 3, 4, 5. Okay. So basically in here, you can see the red. However, for general purpose here, you don't have a red, you can get this one only. Okay. So
Mr. Pham,
they suppose you telling is it general purpose or the precision. Okay. But look like if they put in a red in here, then they will be in the precision. Okay.
Mr. Pham,
Yeah.
A should be a general purpose.
Red here.
No, A, the first one,
Okay. Yeah.
general purpose. So it's silver, which is the fourth column. So it should be 10%, plus or minus 10%.
You mean the A here, right?
Yeah,
Okay. You said 10%, right?
right, because it's on the fourth column.
Okay. 1, 2, 3, 4. We go back here. One, 2, 3, 4. Okay. Okay.
Oh, yeah.
I agree with you. Okay. I'm sorry. They will be silver, 10%. Okay, thank you.
Hey, Mr. Pham,
Yeah,
Wait, so was I right the first time?
hey, Mr. Pham,
yeah.
why don't we do this? Why don't we go down A, B, C, D, and for instance, A, is it general purpose or is it precision?
Oh, what do you mean? That's a general purpose.
Okay, B, is it general purpose or precision?
Precision.
Okay, C, is it general purpose or precision?
General. Precision.
And then, okay, and number one was a general purpose, right?
Right.
Okay,
Yeah, thank you. Sometimes I'm not a good technician. Yeah. Doesn't matter. Now, if you get interviewed for your job, I given you the register. I asking you what the value. Now, what can you do? You understand I've been in engineering for the company for 27 years. I interview a lot of people. Interview just asking for general understanding, not detail. Company get the way company working. They must be training for you, for the company way. So we just asking for your knowledge. Okay. So if I given you this register and I asking you, can you tell me what is the value of that register? Now, who can answer for me?
Can you repeat that again, please?
I said, if you get interviewed and I given you the register and I asking you, tell me what the value of this register. How can you answer that question?
Measure it.
That's what I'm asking. The thing that look like you will in the interview. You have to answer for the correct way. You just not say just measure. What measure?
You need a voltmeter.
Okay. So now,
Or DMM.
okay, I agree.
And open one.
If they asking you that question to me, you can say, okay, do you want me to tell the value by the color code or what? If they say, okay, just tell me about the value by color code. And basically you cannot remember. okay, the table. Then you can say, okay, if I get the table telling you what color equal, then I can telling you, just telling them you know how to do it. However, you have to say the better way. You let me borrow the meter, DMM, digital multimeter. I can tell you exactly the value. That's the only thing we want to end. You got answer that way. Okay. The thing is we training for you to be a technician. That's what you have to deal with. Okay. Now that thing, conductance. So basically, you can reading. They can say conductance is defined as measure of material ability to allow the flow of charge, and it is assigned the SI unit assignment. A lax conductance indicates that the material is able to conduct the current well, whereas a low value of conductance indicates that material does not really permit the flow of the charge. So basically, that I'm just telling you, conductance just opposite to the resistance. Big resistance, they allow less current flow. Okay. However, big conductance, they will be let more current flow. Okay. And this will be, they given to you the conduct, the resistor, and they want you to calculate the conductance. This is the formula. And the unit is assignment. Okay. Now, next, Ohm's law. This is the first law we'll be learning in the DC circuitry. If you're looking into this circuitry here, you get a one power supply E, okay? And the value will be positive here, negative here, okay? And you get the resistor. So in this circuitry here, you can get the current flowing, okay? Positive to the negative, okay? And this current, when they go through resistor and this side of the resistor, positive, and the other side will be negative, okay? Current coming right, resistor, positive, leave it, negative. So that's why when you're in the field, they given you the they draw the resistor, okay? AB. They will be asking you which side positive, A or B. Now, how can you answer that? I just draw that resistor from AB, and I asking you, telling me which side of that resistor will be positive and negative.
A is positive, B is negative.
You don't know until they put a source on it.
Okay. I was just looking.
Okay, now, the answer will be resistor have a no polarity. A can be positive B can be positive. If A positive, B negative, positive, A negative. They don't have any polarity. Okay. However, they will be get the polarity when you telling me the current I going from A to B. Then A will be positive and B will be negative. So you understand that normally you will be hit that in your interview. That's just a tricky question to see the student understand or get a basic training or not. Okay? So resistor have a no polarity. Okay? They can be positive, negative, depend on the direction of the current flowing, current coming, positive, leaving, negative. Okay? So,
And the current is coming from the source.
right, the current have to be coming from power supply. Okay? Now, the relation apply voltage E and the current I, you can get the first formula. Okay? E equal I times R. In this formula, I must be in ampere. That's the unit of the current. R must be in ohm. You understand? Ampere, you can get a milliampere, kiloampere, microampere. Okay? However, when you apply this formula, I must be in ampere and R must be in ohm. And from this formula, you can get another two more formula. If from here, you want to calculate I equal E divided to R. Or you want to calculate R equal E divided to I. Okay? So, in this circuitry here, they given you E is 6 volt, current is 25 milliamp, and they asking what is the value of resistor. That means you want to calculate the resistor, you have to take the E divided to I. 6 volt divided to 25. 25 here is milliamp. Then you must be converting to the amp by multiply by 10 minus 3. That given you 240 ohm. Okay, so everything we go through it, if you confuse it, okay, you just asking. I will try to make it clear as much as I can. Okay, and also I try to make sure you understand. I given you the handout. This is the only thing you need. Reading over and over. That will be help. Okay, one time not enough. More and more time you read it. That will be helping you. Okay, and normally this is the first handout easier. Okay, I go into the detail, but later on I given you handout. You reading handout, I only try to explain how they work it. Okay, and now before we stop it, and I given you something. We don't have to prove anything. If you want to calculate the power, okay, then you can using the formula. They get 3 formula. Okay, power will be equal V times I. Okay, power unit will be a watt. V must be in the volt. I must be ampere. Okay, or you can using P equal I square times R. Or P equal V square divided to R. You get three formulas to calculate the power. Unit will be the same. P must be in watt. V will be in volt. I will be in ampere. So depending on what they given to you, in order for calculate the power. Okay. Now, the thing is you model for the new people. Mr. Thai will be teach you how to download the MSIM7 simulation program, okay, to your computer. In order, you can using that simulation to solving the problem in electronics, okay? Now, last one for today. Characteristics of series circuit. Current is the same everywhere in the circuit. Total resistance equal the sum of individual resistance. The total voltage equal the sum of I times R, voltage drop across the individual resistance. Total power is equal to the sum of power dissipated by each resistance. But that is the general. Now I'm telling you, in general, you can see. This is I'm looking into the circuitry. I know that's what they call a series. You get two different types. One will be a series, one will be parallel. Right now, we're talking about series. When I say this circuitry, you can say, how many resistors? 1, 2, 3, okay? And the current going from power E here, they go to 1, they go to 2, they go to 3. That means all of the resistor get only one current. They will be in series. Okay? So in series, the current go to R1, R2, R3 will be the same. And now if you're looking into the circuitry, you see they draw positive here, negative here. That means the current go to it, positive, leaving, negative. Same thing, R2, coming in, positive, leaving. Exactly the same thing here. Okay, next one. When you're looking here, what is it here?
Reference.
That they call
Error.
common.
What is that?
Or round. Okay. Light up car battery. The black will be round. Okay, that means common for the circuitry. If you measure, they will be get 0 volt. Any circuitry must be get a common. Okay. So in this circuitry, we call a series circuitry. The reason I know series, the thing is, the current go to every resistor here, same thing, only one path for the current flow. Okay, so we already know. Okay, in order to get the total current for the circuitry, that means I want to get a circuitry with that 24 volt. However, only one resistor, not 3. So that's why I need to calculate the total resistance combined. Then they telling you, take R1 plus R2 plus R3 and plus more resistor in series. That's what you get the total resistance. Okay. And then if you want to calculate the current, okay, then you can say I formula equal V divide R. This is a general formula. Okay. However, when you apply to the circuitry, you have to know what V and what R. In this case, UV will be 24 volt. Now, divide to R. This is 3R. So you have to divide by total. So that means you take 2 ohm, add in 6 ohm, add in 4 ohm. So that will be 12 ohm. That will be given to you the current equal to amp. So the current here will be to amp. So then if they say I want to calculate the VR1, what that means VR1? VR1 will be a measure voltage across R1. That means the voltage from here to here, VR1, VR2, here, VR3, here. That means the voltage across.
Hey, Mr. Pham, those answers that you wrote, can you write them in the blue boxes?
What do you mean on the blue box?
Down the bottom, down the bottom.
Now here?
Yeah.
No. I just try to explain. I'm
Oh,
not
okay.
trying to hear.
Okay.
Okay? The thing is, I want they to do it. I just try to make sure you follow it, you understand. When I say VR1, that means the voltage measure across that resistor. And also, I want you to know one more thing. VR1, same thing. The voltage from the A to the B. So the same VA to B. Okay. By the basic definition, VAB equal VA minus VB all the time. VAB means the different voltage between point A and point B. VBC, the different voltage between B and C. Okay. And VR3, same thing, VCD. That means the voltage from VC minus VD. That's what I want you to make sure you understand that. That's a very, very basic. Okay. So this time maybe enough. And sometimes I'm sorry for the student. Sometimes my English is not really good for you guys. First time to listen. However, for a while you can get along. Okay. I came into the United States when I was 30 years old. I don't know how to speak English. I go to the 4 year in the University of Florida to get a BS degree. But that is a technical, I know how to do what to do. But I cannot speak very well English. So the first time I get the offer the job in San Diego, 1981, at General Dynamics, I get a job for about a couple of weeks. I want to quit. The reason is I'm not understand what they're talking to me. However, at that time, I tried to go back to school and try to learn master degree or PhD degree. However, I tried about a month. Not along with that. Okay. And after about 3 months, my supervisor asking me, do you have any more friends? Bring them in. So I understand, I know what to do, how to do. I'm working for that company for 27 years. I'm not looking for the job around, so I don't know much about, the company. I know more company in San Diego. The thing is, I get too many students working in most of the defense company in San Diego. Okay, so that's why anyone doing good in the program, I guarantee I recognize. You've been here with me almost a year. Then I will be happy whoever doing a good job in order to get a technician job. Okay, that's what happened in the past. So any more questions, anything else, or anything you want me, myself, to improve it?
So I was wondering about that. You know how we had to submit this COVID thing? Remember this survey? We have to answer some questions and stuff like that. Which website do I go to again?
Okay.
Oh wait, never mind. I figured it out. Sorry about that. Goodbye.
Okay, any more questions, anything?
Hey, Mr. Pham, just one last thing. For Tech 2 on Thursday and Friday, what do we do?
Okay, on Tech 2, you will be get the lab to be done. Okay. Monday, Tuesday, you don't have a class for Tech 2. For this semester, I'm not teaching theory. The thing at Tech 2 already theory in the spring, last spring.
Okay, Mr. Pham, my question is, what do we do on Thursday of this week and Friday this week? Do we don't worry about it?
Lab.
I'm sorry?
It's on the lab. You will get the lab Wednesday, Thursday, Friday.
Okay.
And I mean, if you already done for the lab vote, you can still get the D lab, right?
But we don't actually come into the lab this week, right?
No, this week, no. Tomorrow you guys see Mr. Tai. No
But
class on Friday.
But we're doing multi-sim, so for Tech 2, basically, no lab. And then if we want to, we can sit in on Mr. Tai's class tomorrow, right?
Exactly.
Okay, all right, thank you.
So
And
basically,
what about Friday? What about,
example, my class Monday, Tuesday, we're talking about electronic. Okay, you on the Tech 1 in the spring, last spring. Then you don't have to do the homework assignment, but you better do any quiz given to you. The reason I want it, that will be helping you to make sure when you're looking into the question in the quiz, you can answer right away. That's what I expect you to do.
okay, Mr. Pham, my question is, so Friday, we don't do anything?
This week. From next week, Friday will be the lab in class.
No, but this week I'm talking about.
He said no.
Okay, that's what I wanted to hear.
Yeah,
Okay, I have a comment, Mrs. Pham.
can you say again?
Hello? I have a comment.
Ah,
Okay, so we and me personally, I understand very well when you explain. It's just sometimes you go too fast because I think you're trying to get through the assignment. That's the only challenging part. But other than that, I understand you when you speak very well. It's not a problem. It just maybe you can slow down a little bit.
yeah, for sure.
Okay.
The thing is, what happened, hey, this is just a over and over, okay, for your guy, and just a very basic. I want you to know, so that's why I can find. However, next week will be very slow, okay? The thing
Okay.
we be learning the new thing, that electronic. You're learning about diode, transistor, amplifier, okay? That means the new for everyone.
Okay.
I will be very slow, guarantee you guys able to understand. Only thing what I want you to make sure, if you cannot follow it, stop me right away and ask, okay? I try to explain to make sure it's clear for you guys. And if
Okay.
someone don't understand what I'm talking about, cannot do it, then maybe you make a wrong choice, okay? This is a technician class working using your brain, okay? Not like assembler. You just do it over and over without thinking. No, this is a problem solving. That's why your job will be more stable. You get paid more skill job, okay? When you know what to do, how to do, technician, you don't care. Your job moves somewhere. You don't want to go, then it's easy for you to get another job if you know how to do what to do. My personal, I never think about layoff. The thing is, they lay me off. I can find a job easier. I know how I do it. I know what I'm doing. Okay. I hope your guy will be feel the same thing. When you do your lab vote, it's not like Mr. Tai try to teach you now. No, that is not the way we want. The way we want is what? When you build the circuitry the way they want and you apply, you measure, you not get the value correct. Now, what can you do? That's what I will be teach you. I will be in the lab, okay, also. Someday, not on 3 days, but will be on the lab one day. You asking me, I will be teach you. How do you fix this problem? Not try to do for you to have you get the correct answer. No, I don't care. The key point is when you hit into the problem, what can you do? If you don't know, I teach you. Write down step by step what next to do, next to do, next to do. Next time you get into the problem, I guarantee you can get the way to solving your problem. Okay? So that is the thing. Everything I said for today. Any more questions?
Do you
Otherwise,
have any assignments?
Simon,
No, I'm saying, do you have any assignments or anything like that, or not yet?
oh, let's see, quickly, okay? I stop share. Okay, now I can share to you this one. Let's see, I didn't see my Zoom. Oh man, this one, how come I didn't see my Zoom anymore? No, quit Zoom. You bring that more up.
The 3 assignments are in the home section below, correct? Fall 2021, check 1 assignments,
Ah, okay.
1, 2, and 3. So in the home, you scroll down.
Yeah, the thing is right now, I cannot share it. Oh, okay. Yeah. So anyway, if you want to do the assignment, yeah, I got a problem with my computer. Okay, so anyway, we'll talk to you guys. Okay, tomorrow.
So
Tomorrow.
no lab this week for Tech 1 or Tech 2, right?
No, tomorrow you get a lecture with Mr. Tai. Go into
All
the
right.
website, click on Mr. Tai, you.
Okay. Thank you.
Okay?
Is there any deadline for the assignments? I just see that you uploaded them yesterday, but I don't see the cutoff time. Does it matter or does it matter?
No, that doesn't matter. Oh, man. This is the first time. Okay, good night.
Good night.
Okay, good night.
Thank you. Good night.
Good night.